in example 3, our function was defined by a set of ordered pairs, and we found the inverse by simply switching the x and y coordinates. So now we're going to talk about how you find the inverse of a function that is defined by an equation. Okay, so you can see down here in example 4 something like this. Okay, so the steps for doing so are right here under find the inverse of a function defined by an equation. There's 4 things you have to do. First thing you need to do is replace f of x with y. Okay, so remember the hallmark of doing inverse functions is switching x and y. So you need a y to be physically present. So you can see down here, your function is going to be given to you with f of x notation, and you know that f of x is the same thing as y, so you need to make that replacement so that you have a y physically present in the equation. Okay, so first step, replace f of x with y. Then you can go ahead and switch the x and the y. Third thing you're going to do is solve for y, and then finally you're going to replace y with f inverse of x. Okay, so that's all you have to do. Okay, so replace f of x with y, switch the x and y, solve for y, and that will give you your inverse function. And so in the last step, when you're replacing y with f inverse of y, or sorry, f inverse of x, you're just using your inverse notation. Okay, so we're going to do several examples of this. Okay, and these examples, they're kind of long, but they're going to illustrate all those facts about a function in its inverse. So hopefully they'll all start making sense to you. Okay, all right, so here's the first one we're going to do. This is example 4. Okay, you get your function. It's f of x is equal to 2x minus 4. And the directions say find a formula for f inverse and give the domain and range of both f and f inverse, then sketch both functions on the same coordinate axes. Okay, so there's a lot going on here. Okay, typically this is a common question I might ask you on a test because there's a lot going on. So you get the function, you're going to have to find the inverse. You're going to have to tell me the domain and range of the original function, the domain and range of the inverse, and you're going to have to plot both the original function and the inverse function on the same grid. Okay. All right, let's start by, I'm going to start, before we get into the inverse function, let's deal with the original function. Okay, we know what its graph looks like. Let's go ahead and put down its domain and range. And then once we do all the stuff for the original function, we can jump into the inverse function. Okay. All right, so we know this is a line, because remember f of x is y, this is y equals mx plus b. This is going to be a line with slope 2 and y-intercept -4. Okay, so I'm going to go ahead and plot the graph of the original function. Okay, so I'm going to go ahead and plot the y-intercept. Okay, and then my slope is 2, so 2 over 1. So I need to go up 2, right 1. Okay, now I know I only need 2 points to determine a line, but for the sake of this, I am going to keep going. I'm going to try to fill out this entire grid. Okay, so up 2, over 1, up 2, over 1, and so on. I'm just going to keep doing this to fill it out. So give me a second to do that. And then I'm also going to go this direction. So down 2, left 1, down 2, left 1, down 2, left 1. Okay, so this is my f of x, the original function. Okay, and I'm going to draw my line through these points. Okay, so let's draw our line. Okay, so now I'm going to go ahead and write down the domain and the range of the original function. Okay, so domain, remember the leftmost point, the leftmost x value is going to be -infinity because this keeps going, corresponding to these x values. And then the rightmost x value, this keeps going up, so it corresponds to these x values. And also, this is a polynomial, okay? No division, no square roots. So the domain is going to be all real numbers. And range, your lowest point's -infinity, your highest point's +infinity, so also all real numbers. Okay. So that's all the information we need for the original function. Okay. So let's go ahead and now work with the inverse function. So we first need to find it. Okay. First thing I'm going to do is replace f of x with y. So y equals 2x minus 4. The next thing I need to do is switch x and y. So the y becomes x and the x becomes y. So I'm going to get the statement x equals 2y minus 4. Okay, it's a very important step. Now you want to solve this guy for y, and that will be your inverse function. Okay, so try to get y by itself. Okay, so I'm going to add 4 to both sides. So I'm going to get x plus 4 is equal to 2y. And then I'm going to divide both sides by 2. Okay, so y is x plus 4 divided by 2. Okay, so that is the inverse function, because this will now be the inverse function. Okay, so we need to talk about the domain and the range of this inverse function, as well as graph it on the same grid as the original function. Okay, and you might be a little stuck because this is kind of a funny looking function just because it's a fraction. Okay, so it might be easier to go a step further and kind of break down this fraction so we can make sense of it. So remember what I've told you 1,000 times. If you want to break down a fraction, you're allowed to take everything in the top and divide by the denominator. So we're going to go a step further. We're going to take everything in the top and divide by the denominator. So we're going to get x over 2 plus 4 over 2. That's equal to our inverse function. Okay. So remember, if you are dividing by 2, it is the same thing as multiplying by 1/2. So this is going to be 1/2 times x plus 4 divided by 2 simplifies to 2. Okay, so here's another way we can write the inverse function, and it may make more sense. Okay, if you put this down as your answer, this is completely correct. Okay, this is completely correct. I just went a step further and broke down the fraction because now this is going to help me. This makes more sense in terms of graphing it, because now you can recognize this as mx plus b. This is also a line. Okay, the line has slope 1/2 and a y-intercept of positive 2. You may not have seen that from this. Okay, that's why we went a step further. Okay, so here's my inverse function. Okay, like I said, a line with slope 1/2 and y-intercept positive 2. We're going to go ahead and graph that. Okay, I'm going to use a different color here. All right, to distinguish between the two graphs. All right, so I'm going to put my y-intercept here. Okay, y-intercept of 2, and I'm going to apply my slope. So I need to go up 1, right 2, up 1, right 2. So they share this point. Up 1, right 2, and I'm just going to fill out the grid just like I did for the other one. Up 1, right 2, and so on. And then in this direction, I'm going to go down 1, left 2, down 1, left 2, and so on. I'm just going to fill it out. And then I'm going to draw my line. Okay, so this is the graph of f inverse of x. Okay. All right, so if we look at the domain and range for this guy, okay, if you're looking at x values, the leftmost x value is negative infinity, the rightmost is positive infinity. Okay, domain is also all real numbers. Okay, again, this is a polynomial. You have a fraction, but remember the fraction does not involve x. X is outside of the fraction. Okay, so domain is all real numbers, and then the range. Okay, this is going to go down forever. So your lowest point is negative infinity. This is going to go up forever. Your highest point is negative infinity, or sorry, positive infinity. Domain is all real numbers. Okay, so remember, one of the facts about the a function and its inverse is that the domain of f has to be the same as the range of f inverse, and that's true here. And the range of f has to be the same as the domain of f inverse. also true here, okay? Another thing to notice is look at this graph, okay? I am going to draw in, remember, one of the properties said that if you graphed the original function and its inverse on the same grid, they would be reflections of each other about the line y equals x, okay? So remember, the line y equals x, that's that identity function we talked about in section 3.4 where the x value is the same as the y value, okay? So the line goes through 0, 0, 1, 1, 2, 2, 3, 3, and so on, okay? I'm going to draw this line in for reference. Okay, I'm just going to make it a dotted line. And what you will see is that the original function and the inverse function are reflections of each other about this line. Okay, so there's the line y equals x, okay, drawn in. Okay, if you were to take the sheet of paper and fold it along the green dotted line, the blue graph would lie on top of the red graph. Okay, another thing to notice, okay, I'm going to take random points, okay, on the original function. Okay, so for example, this is 3, 2. Okay, remember, if you switch x and y, that should be on the inverse. Okay, so let me go look at the inverse. I should see 2, 3. Here's 2, 3 on the inverse. Okay, I'll take another random pair. Okay, so let's say this is 1, negative 2 on the original. Okay, when you switchy switch, you should go see negative 2, positive 1, that point on the graph of the inverse, and it's right there. Okay, I'll do one more for fun. Okay, so let's look at, let me see. Let's do I don't know. I need to pick something. Let's do this one. Let's do 6, 8 on the original. Okay. Pull a switchy poo. It should go to 8, 6 on the inverse. And there it is. Okay. So this example illustrates a lot of things. We talked about how to find the inverse of a function from its equation. Okay, so we did that. And we graphed both the original and the inverse on the same grid and noticed that they are reflections of each other about the line y equals x. If you have a point xy on the original function, then yx should be on the graph of the inverse. Okay, and this also illustrates that the domain of f has to be the same as the range of f inverse, and the range of f has to be the same thing as the domain of f inverse. Okay, we're going to do several more of these so you can kind of get the concept down.